Practice problem number 3 tells us to graph the following system of linear equations. We've talked about linear systems this year. That just means we're working with 2 or more linear equations at the same time. Then we're going to combine the skill of creating graphs with our understanding of linear systems and how we can use a graph of a linear system to find any common solutions. So really, part 1, we're going to have to graph each of these equations. On my whiteboard, I've written both of those equations, y equals negative 3x. Here, we see there is no plus b. That really means that our y-intercept is going to be 0. This is a proportional relationship. Some of you may have recognized this is proportional y equals kx. So it's just going to go right through the origin. That's why our y-intercept is 0 and 0. Y-intercept over here, if we make x 0, if we disappear x, y is going to be a positive 4. So we know the y-intercept there is 0 and 4. For the red equation, our slope, every time x increases by 1, y will lose 3. Our slope is negative 3 over 1 for a rise over run, and 4 over here. Really, this is a positive 1 times x. We just don't write that one. So the slope is 1 over 1, or every time y increases by 1, that's what happens after x increased by 1. So x goes up 1, y will go up by 1 as well. There's our y-intercept and slope for each of those, so we're going to use that to graph these pretty quickly in the interest of time. Remember, we're graphing y-intercepts first, so for the red equation, it goes right through the origin. And then the red equation has a slope of negative 3, meaning it will go down by 3 units for the y value every time you gain 1 on x. If x were positive 1, multiply it by negative 3, that would lose 3 for the y value. Same thing happens as x increases by 1 again, y is going to lose 3 units. We could go ahead and graph that out. There's a graph for the red equation, running straight line through all 3 points. All of the points on the red line are now solutions to that red equation, y equals negative 3x. Do the same thing for the blue one. Y-intercept is 4. So we'll go to 0 and 4 for a y-intercept. And then a slope of 1 over 1 means each time the x value increases by 1, the y will gain 1. Or in other words, we'll rise by 1 unit because y gains 1 unit every time we run, or x gains 1 more unit as well. We go ahead and draw a straight line through those 3 blue dots. And now this graph also, because every point on the blue line represents a solution to the blue equation, every point on the red line represents a solution to the red equation, the common solution, the solution that red and blue share, is where they meet x value of negative 1, y value of 3. So once we create our graph, that's how we can very quickly, one benefit of graphs is they can quickly help us identify common solutions to our linear systems once we understand what a common solution is.